What is going on, guys? Welcome to your 20 something tutorial. I don't even know myself. But anyways, in this lesson I'm going to be talking to you guys about nuclear fusion. Now, in the last tutorial we talked about nuclear fission, which is basically taking a nucleus of something and breaking it apart into two or more pieces. Well, in this tutorial, nuclear fusion, as you'll learn, is just the opposite. We take two or more pieces and combine them or fuse them together, hence the word fusion, into a bigger, heavier nucleus. Now, actually, nuclear fusion produces energy completely in a different way than nuclear fission, so we'll talk about that later on. But first, let me go ahead and show you an example of exactly what I'm talking about. Now, here is what scientists are working on right now. They're trying to take two different elements, which are both versions of hydrogen. These red ones are protons, and these white ones are neutrons. So again, this version of hydrogen is called deuterium. It has one proton, one neutron. This one is called tritium. It has one proton and two neutrons. And what they can do is they can fuse them together to form a helium. Now, a helium in this case has two neutrons and two protons, and it also creates an excess neutron. So you're saying, okay, I can see that fusion is basically taking two lighter nuclei and fusing them together into one heavy nucleus, and also you have this excess neutron, which doesn't really matter for now. So how on earth can this process create energy? Well, it gets kind of different. It doesn't have to do with kinetic energy and gamma radiation. It creates it in an entirely different way than fission. So pay attention. So you know when I talked about that glue, I called it the nuclear glue that held together the protons and the neutrons in the nucleus? Well, that nuclear glue is more commonly called the strong force. Now, whenever you have a nuclear fusion that takes place, in this case, basically it takes less force to hold the heavier nucleus together than the two lighter nuclei. Now, the excess energy gets released, and that's the energy that we capture on. Now, let me go ahead and explain it like this. Well, I'll go ahead and say this first. So, there is some amount of strong force that's holding this proton with these neutrons, and also this proton and this neutron together. Now, there's also a certain amount of strong force needed to hold all this crap together, and there's no force needed to hold this neutron together because it's just one neutron. You don't need to hold it together with anything. So let me go ahead and throw some fake numbers at you because the numbers themselves actually don't matter that much, but just to demonstrate my pretty much my example, I'm just going to go ahead and make up some numbers here. So say a strong force of 20 was needed to hold this together, and say a strong force of 10 was needed to hold this together. So if we add up 20 plus 10, we get 30. So you need an entire force of 30 to hold together deuterium and tritium. Now, whenever you fuse those elements together, you get this helium, which is two protons and two neutrons, and the force it takes to hold together helium, let's just say it's 15. So we have an entire force of 15 needed to hold this side together because you don't need any energy to hold a neutron together. It takes zero. It's just floating there. So this entire side right here takes 30, 20 plus 10, and this entire side right here only takes 15. So where did that excess energy go? Well, it gets released, and that's the energy that we can capture. So remember, basically it takes less force to hold the heavier nucleus together, and the excess energy that's the energy that we can capture and hopefully fuel our vehicles and heat our homes and use in industries and all that good stuff. So that's what scientists are trying to do right now. So you're saying, okay, they have fission. Why don't they just stick with that? It seems like a pretty cool way to, make energy. Well, first of all, they want to use fusion because in this case where you have two hydrogen atoms, hydrogen is basically unlimited on Earth. We got a whole bunch of it. Just look at the ocean. It's basically unlimited. And also, if you remember from fission, it produces harmful byproducts. It pretty much takes uranium and splits them into two radioactive elements that also give off harmful radiations, and we don't want that. All this produces is helium, which is awesome, and a neutron. That neutron isn't going to hurt anybody. Now, aside from that, uranium and plutonium are also very limited on Earth. We're going to run out probably in 100 years, and aside from being limited, the biggest concern is that they produce a lot of radioactive waste, like I said. So that's why fusion is a much more better, I want to say, it's a better way to do things. However, it's a lot more difficult. None of the nuclear plants right now use fusion. They only used it in a bomb, and that's because the hydrogen bomb that they were making, they didn't like need to control it at all. They just pretty much let this thing explode, and it's like so much more powerful than a regular fission bomb. But whenever we use it in power plants, we need to control it. We need to say, okay, we're not just going to explode it randomly. We need to actually release this energy in a calculated way. And it takes very high temperatures. It takes time as an issue and also containing the elements. So again, fusion is the better way, but right now it's just kind of in the testing stages, let me say. So that's where we're looking forward to. Probably in the next 20 years, it's going to become the main source of energy, or at least that's what they tell me. So anyways, thank you guys for watching. Hopefully you'll understand fusion a little bit better now. So yeah, I will see you in the next tutorial.